Hello, this is now the fourth video concerned on lesson number 2 of unit number 3, the operations of integers. In the previous three videos, we were able to discuss how to add properly integers, how to subtract properly, and how to multiply integers properly. We have different rules of signs and different processes that uh, were used to make our solutions easier. So similar possible uh, processes may also be presented for this video, which is concerned on division of integers. Let us go to the material found in the content of your material. I have already opened here the lesson number 2, which is concerned on operations on integers. Again, we will not talk about the contents of this module. You may enjoy them in your vacant time. And we are going to proceed to practice exercise D, which concerns on the four problems of divisions of integers. So let's not waste time. Let us proceed to another window, okay, for the material here. So before we go to answering numbers 1, 2, 3, and 4, would like to emphasize that there is no closure property for division of integers. Okay. When we say about closure property is a property wherein if you're going to combine uh, two different quantities of the same set, it will still result to a quantity belonging in the same set. Okay, let's make it simple. If we are on integers, okay, we are talking about integers. So if we are going to add integers, the result is still an integer. When we're going to subtract integers, the result is still an integer. When we're going to multiply integers, the result is still an integer. In short, addition, multiplication, and addition, subtraction, and multiplication of integers has a closure property. That whenever you will add, subtract, or multiply any number in the set of integers, it will still result to a number belonging in the set of integers. But for division of integers, it's not all the time. Okay, so that's why division of integers has no closure property. Point here is that when we divide fractions, we might entertain when we divide integers, we're still integers, we might entertain fractional results. Our answers would be in fraction form. Okay, that is why we have set rules for fractions starting for this lesson and will also be used for the next lesson. Okay, so what are the rules? Number one, if our answer is a fraction, we need to stay as a fraction. Do not convert into a number with decimal notation. Why? Because there are some fractions that has decimal notations that do not terminate. Let's consider one third. Okay, let us consider one third. When you say about one third, its equivalent decimal notation is not 0.33. It is actually 0.33333 dot, or other references will use the bar here, meaning it doesn't end. So when saying that the one third is 0.33, it's not accurate. It's just approximate. So that is an acceptable answer if we are going to say give an answer in two decimal place, round it off into two decimal places. It is acceptable. So not all fractions. If we say one half, of course it has. If we say one half, it can be written as zero point 0.5. So it terminates. It's okay. But not all fractions can be written with decimal notations with accurate value. So to make to what we got to remove that possible problem, we will need to stay in fractions lang po. Okay, at the same time when we go to algebra later on, and then we might go to simplifying algebraic expressions, specifically on evaluating algebraic expressions, there is a difficulty when we try to evaluate algebraic expressions using decimal numbers with decimal notations. Second rule, if our answer is a improper, sorry, let's say 3 halves. Okay, it should stay as 3 halves. Okay, yes, this is equal to a mixed fraction 1 and 1 half. No problem with that, mathematically correct. But I would like you to use improper than a mixed fraction, because again, when we go to algebra and higher level mathematics, the improper fractions is easier to use than the mixed fraction. So that's the second rule. If our answer is an improper fraction, stay improper. Do not give us the mixed. And finally, and the most important rule when we deal with fractions is to always simplify. Okay. If our answer is 10 over fourths, yes, mathematically, that's still correct. But I would suggest that you convert it into 5 halves, because this is the more simplified answer. So next time, 10 over fourths, even if it's mathematically correct, will not be accepted because it's not simplified. What will be accepted is the simplified form of a fraction. Again, before we go to answering numbers 1 to 3, 4, I need to emphasize, why is it that I'm talking about fractions? Is because the division of integers may result to a fractional form. So it's easy, it's really okay now to start talking about fractions. Let's start with number 1. How do we answer 12 divided by 27? Okay. This symbol here, division symbol, also known as the obolus, will be transformed into a vinculum or division bar. And then this first number we call the dividend will be placed in your numerator, and your divisor, the second number in the division process, will be placed as your denominator. And instead of looking for a integer answer, this will now become a fractional form. So you have here 12 over 27. Rule number 1. Do not give anymore the decimal value for the value for this with decimal notation. Stay as fraction. So yan lang. Number 2. Of course, this is not an improper. That's a proper fraction. You cannot convert it to mixed fraction. But if you can still convert it to mixed fraction, my suggestion, no more. Stay improper if it's improper. As of this case, this is proper, so no problem. And number 3, rule number 3, always simplify. We can simplify this because 12 is actually 3 times 4. And 27 is 3 times 9. We can use the cancellation law for multiplication, wherein if we have the same factors in the numerator and denominator, you can just simply cancel them out. Okay? By canceling doesn't mean zero yung natira. Meron pong natira dyan kasi 3 divided by 3 is actually 1. So meron 1 natira dito. 1 and then 1. So 1 times 4, the answer now becomes 4. 1 times 9 becomes 9. So 12 divided by 27 is actually equal to 4 ninths. 4 ninths lang po. Wag na po yung equivalent na decimal notation. Yan lang po. Tama na po yan. That is our final answer. So applying the same concept concept to negative 12 divided by 27. So you make it a fraction in a fractional form. So you have here negative 12, and you have here 27. And again, negative 12 is negative 3 times 4, and then 27 is 3 times 9. Cancellation law for multiplication allows us to cancel this. Yung negative dito, maging may maiwan na 1, and may 1 dito. So negative 1 times 4 is equal to negative 4 over 9. 1 times 9. Before we proceed to number 3, I would like to emphasize that the placement of the negative number here could be uh, placed in 3 different ways. Number 1, it may be placed in the numerator, just like this, negative 4. The other forms is if you're going to place it in the middle of the fraction, which is also acceptable, or you could actually also place the negative in the denominator. This is also acceptable. So all of these 3 are acceptable versions of the answer for number 2. Number 3, you have 12 over 27. I immediately place it here as a 12 divided by negative 27 is 12 over negative 27. Again, simplify it. 3 times 4, negative 3 times 9. Cancellation law for multiplications allows us to do this. The answer for number 3 is 4 over negative 9. Again, the placement of the negative number here may be similar to here. Could be placed in the numerator, the middle, they are just the same. And finally, we have here the last item, negative 12 divided by negative 27. Okay? The rules of signs for division of integers also follows the rule of signs for multiplication of integers, wherein if we multiply two numbers of the same sign, the answer is positive. If we multiply two numbers of different signs, the answer is negative. Because division is the reverse operation of multiplication, we are going to use the same concern. Just like in number one, we divided two integers with same sign. Our answer is positive 4 ninths. In number two, we divide integers with different signs. Our answer is negative 4 ninths. Number three, two integers with different signs, that where our answer is a negative 4 ninths. In number four, we are dividing two numbers with same signs. So in short, we are expecting that our answer is a positive fraction. But to show it, we have here negative 12 over negative 27. So you could actually factor this out, negative 3 times 4, and also negative 3 times 9. So you have my negative, cancellation law, cancel the negative, cancel the 3. This is the further proof that when you divide number two negative integers, you will result to a positive answer. In this case, positive 4 ninths. Okay, so you can just simply change the values here if you want. You can just use other numbers as practice if you want. It's just up to you if you want to. Okay, this is the fourth and the last operation on integers. So hopefully you have learned something and use this in your review. The next video, we still have one more video for this lesson. The next video is for a practice exercise E, which will include more than one operation. So please be excited and see you in the next video. Goodbye.